This is a lesson on finding values using functions graphs, or function graphs, excuse me. So you can see we have two graphs here, a bunch of things to figure out. Let's get started. So first of all, I'm looking at this first one and I see no values on the X or Y axis here. So that's a big problem, right? This is an unsolvable thing without those values. Okay, we could go ahead and assume what those numbers are, but that would not necessarily be a great idea. Okay, so what if I said, let's see what I have for numbers here. I'm going to call this 1, 2, 3, 4, 5. It doesn't look like we need to go beyond 5. And I'm going to call this 10, 20, 30, and so on. Okay, I don't need to label everything. I just need to know how much each box is worth vertically. So every box up is 10. Every box left or right is 1. Now, if we were to be given this with that scale, could we find f of 3? So what we're given is the input. So the input is 3. And we want to go and we want to find the output. So we're going to go straight up from 3. It looks like it intersects right here. And we're going to go across and figure out what that number is. Okay, so it's purely visual. And we should get an answer of 20. Okay. So 3, we go up to the value here. And we get an answer of 20. What about f of negative 2? So I'm going to go to negative 2 on my x-axis. So if they're going by ones, negative 2 is here. Okay? And it might be a good idea for me to label that. I'm going to go up until I hit, or down if it were down. And I can see that I hit this point right here. And I've got to figure out what this number is on my axis. 1, 2, 3, 4, 5. So the answer is not 5, but they're going by tens. So really it's 1, 2, 3, 4, 5 tens, or 10, 20, 30, 40, 50. So I'm going to put the answer right next to it, 50. Okay. Now again, in a previous video I explained how the input and the output are connected as points on the graph. So this point, 3, 20, is right here. Negative 2 was the input, 50 was the output, and that is this point here. Last one for the first problem is working backwards. We're given a value of negative 2 for the f of x. So that's the height. So the height is negative 2. Actually, when I wrote that question, I think I didn't have a scale on there. So I'm going to change it to negative 20. It's going to be a little easier to see. Okay. And I'm looking at, here's negative 10. Here would be negative 20. Okay. I'm going to look left and I'm going to look right. And no matter how far I look, the graph, the pink graph, never reaches a height of negative 20. So it says find x where f of x is equal to negative 20. There is no solution for that. Okay? No solution is a perfectly acceptable answer in some cases. Let's take a look at the second example. Now, if you can read my chicken scratch here, this graph represents the distance from a point over time. So here's our time, and here's our distance. Of course, my variables or my lettering should probably match up, lowercase d here. And scale is important, so let's kind of investigate here. 5, 10, that would be 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So it works out nicely there. That was good. And the y values, or the height is going, or distance, excuse me, is going up by 100s. So I like to add in stuff that might be pertinent. Here's a 700, 600. I don't know what's going to be needed. So let's just take a look. This is the input. So I'm going to go on the x-axis to 30. I'm going to use colors again. 30 on the x. So 5, 10, 15, 20, 25, 30. I'm going to label that point because it matters to my problem here. I'm looking for what's the value. So I'm going to go up. Oh, it's a nice point. I'm going to go sideways, left, back to that dependent variable axis. And the answer is 500. Okay, so each of the numbers is part of a point, and you just got to make sure you keep track of which one is correct. 43. 43 is somewhere in here. Okay, so approximately right there. If I could zoom in, somewhere in that region. And I'm going to go straight up. Looks like I'm probably going to have to estimate here. Okay, looks to be a little bit shy of here, which is definitely that high. So I better be underneath that 600. So I'm going to have to estimate. Okay, so if we're looking at 500 here and 600 here, wow, let's fix that. Okay, this would be about 650, and this would be, 550, and this would be about, I would say, pretty safe to say that's around 575. So I'm going to say that D of 43 is about 575. Now, since this is a linear graph, and we have clear, distinct points here, we could calculate the equation for that and come up with an exact answer, but that's not what this lesson is about, okay? All right, let's do that last one. Find when D of t is equal to 200 feet. So we're going to find 200 feet here, and we're going to work backwards. Go across, and then down. That one looks like a nice one. 5 before 60 is 55. So we're going to say 55 minutes. So that's how you use graphs to both evaluate and solve equations.